let's get started. Hello everybody. Today we are going to solve some Leecode questions. I think my stream is up. Is it up? Is it up? So we can check. I think there are a few people here already. So 4 viewers. All right, so today we are going to solve a few questions. We have 2 new questions to solve and some questions I solved during the week. I posted a few videos during the week, so if you're interested, you can still go back and watch them. So today we are going to start with a new question, and then I will explain the other ones I solved the other day. So let's start with shuffle the array. So this is an easy question and it's in the category of arrays, so it is suitable for beginners. And yeah, so let's give it a try. Given the array norms consisting of 2n elements in the form of x1, x2 all the way to xn, y1, y2 all the way to yn, return the array in the form of x1, y1, x2, y2 up to xn, yn. Okay, so example 1, input is norms is equal to 2, 5, 1, 3, 4, 7, n is equal to 3. Now the output will be 2, 3, 5, 4, 1, 7. So first of all, we need to understand what n is. N is actually the middle index, right, of the array. So meaning if n is equal to 3, then the entire length of this norms array will be n times 2, which is what the question said here. So consisting of 2n elements. So half of norms, right, will be in the x category, and the other half will be in the y category. So let's quickly show an interpretation of this. We'll be given this array here. Is my stream still working? Let me check. We are sort of up, but I'm not sure. So let's take this here. This is norms. Oh. Please don't fail me. This internet. So here is our input array. Here is our input array. Oh my God. N is equal to 3, so n is equal to 3. We'll put n here. N is equal to 3. Now n, like I said, is to represent the middle of this array. So it means index 3, right? And index 3 in an array is the 4th element in the array. So n will start from this point here. So we want to swap the values, right? So we want to swap the values to have x1, y1, right, all the way to xn, yn, like this, right? So how do we know which elements belong to the x category and which other elements belong to the y category? Well, that's actually simple. So since we know the middle of the array, right, every other element towards the left will belong to the x category, so we'll put them as x, and then every other element to the right from n will belong to the y category. So x1, right, will be 2 here. So this will be x1 and this will be y1. And here is y2 and y3. So we have x2 here, x3. So we want to transform the array, right? So in order for us to do this, we need to create a second array where we will keep the transformation or the transformed form of the nums array, which is the actual input array we've been given. So nums here, right? Nums here is equal to this. Okay, so now for us to swap these values, we need to traverse the nums array and then append to our new array the values in the orders we want them in. So in our iteration, right, let me just put this in green. So in our iteration, by iteration I mean iterating through the nums array, which is this our input array here. We'll first insert x1. So at index I, right, this is index I, we'll insert number 2 into our, so I'll call this res, which is equal to result. So nums at I, right, nums at I here is going to be 2. And then the second number we need to insert would be y1, which is at index 3. So we'll put 3 here, and then we'll do the same thing. We'll put 5, x2 will be 5. Then we'll look at the y section again and insert y2, which is 4, x3 is 1, and y3 is 7. Now, our iteration will be based on half of the length of the array. In other words, n, right? So we have to iterate through the array n times, right, in order to perform this operation. Now, the time complexity of this operation is going to be O of n, right, because we are iterating just once, right? And also we are iterating half of the length of n. Now, half of the length of n is also based on the length of n, so we can't really say this is going to be O of half of n, right? That's literally the same as O of n. So the time complexity of this will be O of n. Now let's pass on to the code and see how we can solve this. So I'll come here, right? We are looking at shuffle array, and the question here is, so here's our input to this function here. We have nums, which is an array of integers, and n, which is the middle, right, of the nums array. So we'll first of all iterate through the nums array. Okay, you know what, let me just, the reason why I use my code editor is, number one, to be able to push it to GitHub, and also to get auto completion of code. So we'll create our shuffled array. I'll call this shuffled, right? Shuffled, okay, shuffled array. And then we'll create two variables. We'll create the I variable, which is our index, and we'll use this to iterate through the nums array. So I, and then we want j as well. J will be the second starting point. Okay, you know what, let's call this x and y, right? And x will start from index 0 and y will start from n, right? And then we will iterate. So we'll use a while loop. We'll say while x is less than n, right? While x is less than n, we want to okay, we want to insert into shuffle, right? So we append into shuffle nums at x, right, and shuffled dot append nums at y, right? So, and then after insertion of these values, we then increment x and y. So x will be incremented by 1, s plus equal 1, and y is also incremented to 1 as well. So we have this here. Let's quickly adjust this. Okay. So then we can just return, the function wants us to return a list of integers. So we return the shuffled array. And we can just test this out to see how it runs. So let's copy this test case here. And I'll say solution. Let's call the solution test, right? Is going to be equal to solution, right? And then we call the shuffle function, pass it our list, and n is going to be equal to 3. So we print this out, print solution test. So we should have the transformed version of the array. As you can see, this works pretty well. Okay, so again, I can still explain why we iterate up to n, right? So the reason why I did this is because n is the middle of the array, right? So ix, which is our index iterator, can only be incremented up to 1, right? So we said while x is less than n, right, keep incrementing x until x becomes equal to n, right? Until x becomes equal to n, which is at this point, then you stop. When x becomes equal to n, you stop incrementing x. That's basically what the condition, the while loop condition is. And then at the same time, we simultaneously increment y, right? And by the end of the iteration, when x becomes equal to n, which will stop the loop, y will also be outside of this nums array, which is not possible. So we will terminate the loop at this point instead. So yeah, so let's go ahead and test our solution. We can copy this and simply paste it in Leecode. So we will do this. Come to Leecode here and paste it like this. Yep. Okay, so let's go ahead and run this function. Now all the test cases have been passed, and then we can submit our solution. All right, this solution actually works pretty well, and we passed all the test cases, 53 over 53. Okay, let's move on to the next question. I will erase this board here, and we move on to the next one. So the next question is also an array question. Number of good pairs. So given an array of integers nums, return the number of good pairs. A pair I, j, right? These are all indexes. A pair I and j is called good if the number at index I is equal to the number at index j, and I is less than j. Okay, so here is a question that might seem a little bit tricky, but since it's an array based question, we are not going to do any extra DSA topics on this, but we can just use simple methods to solve this question. So first of all, the conditions for us to determine a good pair is if the number at the index, the first index, is the same as another number at a different index of the same array, and those indexes are not equal, meaning the first index will be less than the second index. So let's take a look at this example here and be able to come up with a solution. Let's paste this here and go ahead. All right, so we have our nums array, right? You call it nums, yeah. So nums array is this array here. And let's see, where's my pen? And we need to determine, right? We need to determine if this has any good pairs, or we need to determine the number of good pairs that it has, right? So looking at this, right, we're just going to use like some simple logic, right, to determine this before moving on to coding the actual solution. So every number in this array has an index, right? So starting from 0, 1, 2, 3, 4, and then 5. Now, our condition to determine a good pair is such that the number at a particular index in this nums array here has to be the same as another number in the same array, but at a different index. So, for example, we have 1 here, right? When we look through this array, we can find 1 also at this point here. Now, first condition is passed, right? We found duplicates. We found numbers with the same values. Now, the second condition will be that the number at index I has to be less than the number at index, the second place where we found the number, right? So the first number's index should be less than the second number's index. So in this case, we have 0 and then 3. Obviously, 0 is less than 3. 1 is equal to 1. So this makes this particular pair a good pair. So we have 0 and then 4. So this is our first good pair. We do the same thing, right? We look through the array again. We found another 1 here, right? So we have 1 and 1. So again, 1 is equal to 1. The index of 0 is less than the index of 4. So we found another good pair again. So this will be 0 and, sorry, this was 3. This was 3 and this is 4 now. So this is 4. Let's erase this quickly and write the actual value there. So 3. So this is number 2 good pair we found. And let's move on to the second one all the way to the end. So we keep looking until we hit the end of the array and then we stop searching. Then we move on to the next number, right? So we go again. We stop at this point. We've not found any other pair, right? We start with 2 now. We go ahead with 2. Let's erase all of this. Okay, that was okay. Right, come on. Okay, you know what, let's just use a different color. So here we start with 2, right? And then we search through the array. Is this equal to 2? No. 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 Then we move on to 3, right? 3 is our new target, right? Our new target at index I. So we continue looking. Is any other 3 in this array? Yes, we found another 3 here, right? 3 is equal to 3. Condition 1 passed. 2, which is the index of the first 3 that we found in the array, is less than 5, right? So this is another good pair that we found. So we put 2 and 5. So this is 3. And we move on to the next item in the array. So we have 1. 1 is our next item. 1, and then we found another value which is equal to 1. So we have 1 and 1. And their indexes are obviously you know, good for this condition. So 3 is less than 4. So this is 3 and 4, right? So we found the fourth item. Then this, we come to this place, right? Until we hit the end of the array. We always go all the way to the end. So since we're at the end here, we stop our comparison because 1 is not equal to 3. So then we move on to the next item, and then we compare it to this one, which is not a good pair, and we compare 3 to, you know, nothing else. So we stop here. So far we found 4 good pairs, right? So let's check here and see if that's correct. And you can see, yes, it is. So how do we code this? Well, there are a couple of techniques we can use to solve this question, but the easiest one we can do is to iterate through the array and take 2 numbers at a time, right, from the nums array, and compare them simultaneously until we reach a point where they overlap, right? And then we stop, and then we go again, we iterate. So let me show you how to do that. So first of all, I'll come here and here. So we have identical pairs, right? That's the name of the function we'll be given, num identical pairs. Okay, and here is our input. So we'll first of all start our loop, right? We'll start iterating from I being equal to I being less than the length of the nums array, right? And we'll go all the way to the end each time. Then we'll start j at this point, right? So we're going to use 2 points. Let me erase all of this again. Let me show you how I'm going to do that. So I'm first of all going to start from here. So I'll put I here, right? Now this I will help me iterate through the array, right? I'll move from this point to this point to this point all the way here. But then I'll need another variable, right? J, we'll put J here. J here. So each time we are iterating, we are going to compare the values of I and J. Now this will help us placing I and J at different points, right? Will help us, you know, bypass the first condition, which means 2 points at different positions, but the first point has to be less than the second point. So automatically I is 0, J is equal to the length of the nums array minus 1, right? Whatever this is going to be 6 minus 1. So this is index 5, right? And then all we need to do is to compare the values of I and J, right? The values of I and J, or the values at I and J. So the value at I here is going to be 1. The value at J here is going to be 3. So when we compare these values and they are not equal, we don't need to count if they are good pairs or not. So here, let's just do that quickly. So when we move I, when we start I at this point, right, I is going to be here. Then we start comparing I to J, right? So we say while I is less than the length of J, right, let's keep incrementing J. So we'll increment J from here. So is this equal to that? No. Is this equal to this? Yes. So we'll increment. So let's call this C is going to be equal to 1. And then we move this again from here to here. And this is going to be equal to 2. Okay, let's just put 2 here. Yeah, this is going to be 2. And we'll move this from here to here, right? It's not equal from here to here. It's not equal. So the condition, the loop will stop here, right? And then we increment I to this point again and compare, right? Is this equal to this? No. Is this? Then we begin the second loop, right? This here, here, and here. And since it is not equal, and while I is still less than j, right, we continue incrementing j. So, and when we reach here, we stop our loop. We don't even need to compare j at I here anymore. So we move I to this point again, and then we increment j from here. So here they are equal, right? So we found another equal value. So we increment this to 3. So this is going to be 3. And then we move, we move j from here to here. This is going to be 3 against 1, which is not equal. So we just stop here. We move I to this point. We increment j. So j always starts from index, from the last item in the array, right? That's where j will always start from. And then we increment j again to this point here. J is going to be equal to I. I mean, the value at j here is going to be equal to I. So we increment j again, right? We increment j. I mean, we increment c, which is the count. So this is going to be equal to 4. And then we move this again from here to here. I mean, we don't need to move it from here to here. We just stop at this point because I has to be less than j, right? So we move I again. We increment I in the next iteration. And here we will just stop the loop at this point, right? We'll stop the loop at this point because we cannot increment I to be equal to, j. Okay, so again, we need to understand two things. First of all, we need a first loop, right? An outer loop. I'll put loop 1 here. Loop 1 to increment value of y, I mean value of I. So increment I. And then loop 2 will increment the value of j. Increment j, right? Now j and I will have starting points, right? So the value of I here is going to be equal to 0 at first, right? And then the value of j, right, is going to be the length of the length of nums array minus 1. So it's going to start at this point. Always, in every iteration, we redefine j, right? We give it a new value in every iteration. So I'm just going to come here now, right? And we'll begin writing the code for this. Okay, so first of all, we need to define the values of I and, begin our iteration. So while I is going to be equal to 0, we need I and the count, right? So we'll say I and count are both equal to 0 and 0. Okay, so while I is less than the length of nums, right? While I is less than the length of nums, we define j, right? J is going to be equal to length of nums minus 1. Okay, so now while j is superior to I, right? While j is superior to I, if the nums at I is equal to nums at j, right, then we've passed both conditions. First of all, we need both indexes to have we need the first index to be less than the second index, and we also need the values at these indexes to be equal, right? So in this case, we are now allowed to increment the value of count. So we'll say count plus equal 1. And then, right, so after this, when we reach here, we can then increment the value of I. So after iterating through the array after iterating through the array and incrementing j. Sorry, I forgot to increment j. So j, we don't increment j, we decrease j, right? J minus equal 1. So after reducing the value of j up to this condition here, I mean when this up to the point where this condition becomes false, right, we stop this loop and then we go back to the main loop. Right now, when the main loop runs, after the second loop we need to increase the value of I, so we do plus equal 1, and then this array returns an integer which is the value of count, and then we can just try this out. So I'll call this solution test. It's going to be equal to the solution, and we put this here. Let's take a look at this one here. So we have 1 2 3. We copy this input array, and let's hope our output, the result, is going to be equal to 4. So here it is. I'm going to open the code editor here. All right, so we expect 4 to be the result of our solution. So let's run this again and run this function. All right, 4 is printed, which means we've successfully solved this this question. Now there are a few things we need to understand about this question. First of all, the time complexity, right? So the time complexity of this this solution, right, is going to be O of n squared, because we are running a nested loop, right? So this automatically increase our time complexity to O of n squared, which is also a quadratic, I think so. I probably forgot. Anyways, O of n squared. So our time complexity for this solution here is going to be, oh sorry, let's take this here. Okay, this is going to be O of n squared. All right, so let's write our solution in Leecode and test it out. So we take this from here to here, and we go back to Leecode and paste our solution. All right, so now we can test this out. Let's run this and see. Okay, we've also passed all the test cases, and let's submit. Okay, as you can see, the runtime is really low. I'm not sure how they rank this, right, or give the ratings for this, but this is not really very good. This is not very good, but it's not bad either. So for a beginner, you don't expect yourself to like really beat all the other solution, right? As you can see, it changes all the time, and I think this also depends on your internet speed as well. But we can't argue the fact that this is O of n squared time complexity for this solution. And in terms of memory, right, in terms of memory, we are not using up a lot of memory, so which is pretty good, because we are not creating any new value into our memory. We are not. So the way this is done is when you create a new array and start inserting values into the array, you create a new space in memory, right? So it means you're incrementing the value in memory, so you don't want to do that. Yeah, so that's about it for this solution. We can look at these other problems as well. So these are some problems we solved during the week, and this is, sorry, hold on, I need to attend to this quickly. All right, so let's take a look at running sum of one D array. Now this is also a fairly simple question. What this question is asking us to do is to add mutate our array. First of all, we need to do this in place, right? Let's read this. Let me go over the question again. Given an array norms, we define a running sum of an array as running sum at index I is equal to sum of norms at index 0 starting from 0 all the way to norms at index I, right? So here's an example. We've been given this example here, and this is our expected output. Now, what we can do in this case, right? What we can do in this case, let's just clean up the screen here and paste the norms array here. So how do we arrive at the solution? We want to create we are mutating this array again in place, right, but changing the values. So our output is obtained by, first of all, we start from index 0, right? We impute the first number and add, you know, the number before it. But in this case, we don't have any number before the value at index 0, so we simply put 1 here. Now the next value, right, is going to be this value here plus the value before it, right? So the previous value, and this is going to be 2 plus 1, right? 2 plus 1 is going to be equal to 3, and then we do the same thing here. So we are going to when we get to 3, right, we want to add every value before it. So we want to add 1 plus 2 and then plus 3. But we already determined, we've already calculated 1 plus 2, right, which is 3. And this value has already been inserted in the array. So all we need to do is to get that value and add it to the current value, right, which is equal to 3. So this is going to be 3 plus 3, and this is going to be 6. And we do the same thing here. So to 4, we'll add every value before it, right? So we'll add 1 plus 2 plus 3. And then we'll add 4 to that value to insert the current value. So this is going to be 1 plus 2 is 3, which is this value here. 2 plus 3, 3 plus 3 is 6, which is this value here. And then we just take this value here and add it to the current value. This is going to be 6 plus 4, and 6 plus 4 is equal to 10. So this should be our output array. And for us to do that, we simply need to iterate. Okay, running sum of one D array. Okay, we simply need to iterate from index 1, right? We start our iteration at index 1 simply because we don't have any values in front of index 0, the value at index 0, which is 1 here. We don't have any values here, right? This is simply empty, so we can't access any value before it. So we take 0, right, in value at index 0, and we put it here. We insert it into the array, right? We just mutate the array in place. We are not creating a new space in memory. So we just take this same norms array, and then we access the value at index I. So in our iteration, right, index I will be from this point here, from 2, right? So we had 1 in the array, and then we say value at index I, right, which is 2, is going to be added the previous value, right? So index I minus 1, which is what I did here, index I minus 1. So index I is 1, minus 1 is 0. So 1 minus 1 is 0. And what value do we have at index 0? The value at index 0 is 1. So we'll take 1 and add it to 2. This becomes 3, and then we'll do the same thing again once we reach index 2, right? And at index 2 we have the value 3, which is really ironic. Anyways, so we have index 2 means the third element in the array. So we add the previous sum that we performed to the current value. So this is going to be 6, and then to 6 we'll add 4, so we'll get the last value, and this is the solution for that. All right, so the last question is move zeros. Now move zeros is pretty straightforward and at the same time a little bit tricky, and we also have kids with the greatest number. So if you want to see the solutions for this question, I recorded a video the previous day. I recorded a video on, let me show you that. I think there are 2 videos that explain those questions, and you can have access to them and see how I solve them. Also, the solution to these questions are on my GitHub repo right here. So let me quickly push the new question solve to GitHub. So do git add git push origin. We need to commit this here. Git commit -m. So we did Leecode 1470 and Leecode 1512. Okay, then we can push this git push origin main. Okay, all right, so this has been pushed to GitHub. When we refresh this page, you can see the new questions have been added, and you can have access to this and see the solutions to this question. All right, that's it for today. My time is up, and I will see you on another day, so for a new stream, right? Okay, take care, bye.